We're going to start. So in this example, we have the following scenario. Question says, a survey indicates that people keep their cell phone an average of 1.5 years before buying a new one. Okay, we have some important information here. The average 1.5 years before buying a new one. The standard deviation they found to be 0.25 year. There we go. So two important pieces of information here for you. A cell phone user is selected randomly, right? Question says, find the probability that the user will keep his or her phone for less than 1 year before buying a new one. Okay, another important piece of information. They'll keep the phone for less than 1 year. And they know this is normally distributed. The data is normally distributed. Okay, so what are we going to do? We're going to find this probability. This is the graph, right? The mean or the center is 1.5. Remember that for a normal distribution, the mean, the center is located here, 1.5 years. And then based off of the standard deviation, we can divide this up. All right, very good. So less than 1 year. So you're interested in knowing what is this probability. How do we find this probability? What is the keyword? Is it the left side? Is it the right side? All right. So what is a good lower bound here? What is a good upper bound here? Based off of this information that we see here, which one is the correct answer, right? And note that we are using X. Why it is not Z? Because remember, when you're working with Z, mean is 0, standard deviation is 1. But look at the data here. The mean of the data is 1.5 and the standard deviation is 0.25. They are not the same. So you have your X values. Mean is 1.5 and the standard deviation is 0.25. Very good. The good lower bound and a good upper bound based off of the information that you have here. All right. Perfect. Thank you very much. So let us share the result with you so everyone can see the result. So this guy says, hey, what is the probability that X is less than 1 year? X is less than 1 year. We want to find the area. We want to find the probability that X is less than 1 year. So as usual, we're going to use our calculator, right? In using our calculator, we're going to turn on the calculator, second vars, and this is a normal distribution, and we are finding the cumulative area, cumulative probability. We're going to go to normal CDF. So second and vars and normal CDF. Very good. In the normal CDF, as you mentioned, since we are finding the area to the left side of 1, a good lower bound can be -10, it can be -100, but take a look at the average here, 1.5. So you can select -100 as well. It doesn't change the value, it doesn't change the probability in very largely, it's just very small in decimal. So let us stick to negative. So again, for negative sign, you're going to use negative here, not subtraction, everyone. 10. What is the upper bound? It says it stops at 1, all right? So my upper bound is going to be 1. lower bound is -10, and the upper bound is 1, right? But what is the mean? What is the standard deviation? Is it 0 and 1? The mean is 1.5, so we have to change it. Be careful, guys. If you're using X, you need to change your mean and change the standard deviation. Mean is 1.5, as you can see, as it's highlighted here, 1.5, and standard deviation is 0.25. 0.25. So let's do the calculation. Very good. If we do the calculation, what do we see here? We see the probability is very, very small, all right? So if this probability, the probability that a random person keeps their phone less than a year is about, so let's see, we need to write this down, 0.022, and since it is 5, you're going to round it up to 8, so it is going to be 2.28%, which is a low probability.